going to review the ALEKS topic, finding the vertex, x-intercepts, and axis of symmetry from the graph of a parabola. So it says use the graph of the parabola to fill in the table below. So let's see what it asks us to do here. So the first thing it says is, does the parabola open upward or downward? Upward means that it gets larger this way, okay, and notice that anytime you have a graph, right, we can put little arrows here, so it's going to continue to open upwards. So in this case, we are opening our parabola upwards. It says find the coordinates of the vertex. Now the vertex is either the lowest or the highest point on the graph. So let's make a little note of that here. Okay, it is either the lowest or highest. Okay, so we come over here to our graph and we want to find the vertex. We go and we say, okay, where is the lowest point? And it is right here. Okay, this is also, if you notice, like the center of our graph. Okay, and we'll talk about this in a minute when we talk about the axis of symmetry. So they want to know, what is this point right here? Well, anytime we list a point, we always list it with the x value and the y value. So we come over here and we go, okay, well, the x value is -2 and the y value is -2. So my vertex for this graph is the point -2, -2. Now the next thing that they want us to find here is they want to find our x-intercepts. And remember that anytime we have an intercept, it's where the graph touches that axis. So this is our x-axis here. And we're looking to see, does our graph touch our x-axis? Because notice it says that we may not have any, okay? You could have more than one x-intercept, or you could have none. Okay, so we look at our graph and we say, oh, it touches the x-axis right here. So we have an x-intercept here, and we have an x-intercept right here. And so they want us to list out what our x-intercepts are. So our x-intercept here is -3. That's this one right here. And then this x-intercept over here is -1. Okay, so those are our two x-intercepts. The last thing they ask us to do is find the equation of the axis of symmetry. Remember, symmetry means same. So they want to know, if you were to draw a straight line through this graph, where would that go to where it was symmetrical on both sides? And remember, we talked in the last screen that is actually through the vertex. So if I was to draw a line straight through this graph, okay, this is our axis of symmetry. Okay. Now, here's where people tend to mess up. They simply list the point -2, because notice that is where it goes through the middle of our graph at x equals -2. But they want an equation, and that's the key word that you're looking here for, equation. So the equation here would be x equals -2. Now, if you just put -2 and you don't have that x equals, you'll get it marked wrong. So please make sure you're very careful there and you give them the equation, okay? Our graph could be going the other direction, okay? It could be flipped on its side, and if that was the case, the axis of symmetry would actually be something like y equals -5 or y equals 4. So it's really important that we make sure that we include this first part here, this x equals, so that they know which direction our graph is pointing. So let's look at another example here. So here's another parabola, okay? And they want us to do the same thing, okay? Does the parabola open upward or downwards? Well, we see that this one also opens upward. Okay. They want us to find our vertex, which we know is the lowest point on our graph, which would be right here. So we come in and we say, okay, that has an x value of 3. And it has a y value of 1. So our vertex is the point 3, 1. Now, it asks us if we have any x-intercepts. So we come back and we look at our graph and we notice this graph never touches the x-axis. Never touches this line right here, our x-axis. Therefore, there are no x-intercepts. So we would say no, or we would just type in the word none. Okay, there are none. Sometimes that happens, and that's okay. Now, we then need to determine our axis of symmetry. Remember, our axis of symmetry is the line that shows the separation between the graph where it's symmetrical on both sides. Remember, we talked about it goes through the vertex. So here is our axis of symmetry. Our axis of symmetry goes through the x value 3. So our equation for our axis of symmetry is going to be x equals 3. Notice that your axis of symmetry, the x equals 3, is also the same x value as your vertex, which makes sense because the axis of symmetry goes through your vertex. Let's try one more example. Okay, so here's our last example. Notice this parabola looks different than the others. This one is opening downward. It's getting larger. It's opening downward. So therefore, our parabola opens downward. We then go to find our vertex, which we know is the highest or lowest point. Now, when the parabola is opening downward, the vertex is the highest point on our graph, okay? Everything goes downhill from here, okay? So highest point and then down, down. So we need to find our x and our y value at this point. So here's our x, and here's our y. That wasn't a very good straight line, was it? Okay, so our vertex has an x value of -3, has a y value of 4. They want to know if it has any x-intercepts. Again, x-intercepts is where the graph touches the x-axis. We see an x-intercept here, and we see an x-intercept here. So for this first one, it has this intersects the x-axis at -5. So yes, we have x-intercepts. And it touches at -1. So we have two x-intercepts, -5 and -1. Last thing we need is our axis of symmetry. We know our axis of symmetry goes straight down the middle, cutting our graph into two symmetrical pieces. And that cuts through the axis at x equals -3. Again, the axis of symmetry goes through the vertex. Notice our equation is x equals -3, and our x value for our vertex is also -3. I hope you found this video helpful. If you have any additional questions, please reach out to your instructor. Have a great day.